Hi friends, good afternoon. Today we are going to discuss with another section of differential equation. So in previous class we seen how to find a complementary function, particular integral, and then how find the solution of a higher order linear equation. Today we are going to discuss some entirely different area, some special kind of differential equation, right? So let us discuss directly. See, first kind is exact differential equation, right? Exact differential equation means, see, any differential equation given in this format, p dx plus q dy is equal to 0. p dx plus q dy is equal to 0. So this kind of one equation you get means, first you have to check whether this differential equation is exact or not, right? How we check exact or not? So identify the p value and q value from the given equation. Then you find dou p by dou y, partial differential of p find, and you find partial differential of q, dou q by dou x. Here p is a function of x and y, q also is a function of x and y. Then with respect to y you differentiate p, and with respect to x you differentiate q. If this both are equal means you can claim this function is exact. Understood? If it is exact means what is the solution? You know, integral p dx plus integral q dy is equal to a constant, here not x. That means during the second part integration time you should not consider the term containing x. One problem I will do, then you will get more idea about this, right? See, look here. So this is integral p dx plus q dx, q dy is equal to c. What is q dagger? P is q dagger is, that means it is the term of q which not contain what? Which not contain x, right? So let us directly go to the problem. See, one problem given like this, then what is the solution, right? Alright, so look here. Here one differential equation. First I am multiplying throughout with the dx, then what I can write? X plus sin y into dx plus x cos y minus 2y into dy equal to 0. I multiplied throughout with dx. Now you can write this in the format p dx plus q dy equal to 0. What is p? This is p. What is q? This is q, right? Now checking exact or not. What is dou p by dou y? Dou p by dou y is equal to, with respect to y, x is constant, is sin y doing cos y. Now what is dou q by dou x? With respect to y, x doing cos y constant, x on doing 1, and minus 2y is a constant with respect to x, then cos y only. Then dou p by dou y is equal to dou q by dou x. That means this differential equation is exact. Exact means what is the solution? Integral p dx. What means p? X plus sin y into dx plus the term which not containing x. This term q containing integral q, this term containing what? Look here, this term containing x, right? That we need not consider. Then q dy, q is without x, that means minus 2y dy equal to c. Now this is x square by 2, with respect to dx integrating, with respect to x integrating, sin y is a constant, dx on doing x, right? Then sin y into x minus 2 into, with respect to y square by 2 to cancel, right? Equal to c. So this is the solution, alright? So exact differential equation we solve like this, alright? Now let us go to another kind of differential equation. that is Euler-Cauchy differential equation. Euler-Cauchy differential equation, right? See, this differential equation is like this only, right? Right. See, suppose one equation, see, if x power n come here, differential power also n. If x power n minus 1 here differential power also n minus 1, right? If differential not there means here no x power, here there is a constant only. For example, x square d square y by dx square minus x dy by dx plus y is equal to some sin x cos x anything, okay. So like this one equation getting means the trick is you immediately substitute x is equal to e raised to z, x is equal to e raised to z. You immediately make the substitution x is equal to e raised to z. This kind of pattern one equation getting. Then what, log x is equal to what? Z. Then dz by dx what? 1 by x. Now dy by dx what? Dy by dx is equal to dy by dz into dz by dx. This cancel. That is dy by dx is equal to dy by dz into, right, dz by dx we already got, that is 1 by x. Then x dy by dx equal to what I can write? Dy by dz. Now d by dz I am taken as capital D. Then x dy by dx I can say dy. Then x square d square y by dx square I can write d into d minus 1 into y. X cube d cube y by dx cube you can write as d into d minus 1 into d minus 2 into y. This pattern you are going to write. Understood? Then you can simplify and find the solution. This kind of pattern one equation given, we call it as Euler-Cauchy differential equation, right? Now let us see with one example how we can solve this, right? See, here one equation given, right? So how we first we write as per the theory I told, what is this kind of equation, we call it as Euler-Cauchy differential. In Euler-Cauchy differential equation, what we consider x is equal to e raised to z, am I right? Then z is equal to log e u, right? Log x, right? Then what I told, dy x dy by dx is equal to dy x square d square y by dx square, what is that? D into d minus 1 into y. This all we derived in Euler-Cauchy differential equation. These values and all we already known, we already derived. Understood? Now look here. Here x square d square y by dx square, that is d into d minus 1 into y minus 2 into what is x dy by dx, that is dy minus 4y equal to x square. So I can write this as d square minus dy minus 2 dy minus 4y equal to x square. Am I right? Alright. Now look here, this that here I made a mistake. Here this y and all we taking out, right? Y and all we taking out. Then here d square minus dy. Here also 1 d square y, right? Am I right? Then here 2 dy. Alright? Yes, it is correct. Here what? 4y. Okay. Now 4y we can take out. Then what? Here d square minus how many d part? Here dy minus 3 dy minus 3d, say d square 3 dy minus 4y equal to what? Equal to x square. Am I right? Alright. Now this you can write as d square minus 3d minus 4 into y equal to x square. Alright. Then what I can write, y is equal to x square divided by d square minus 3d minus 4. Right. Now you know how to solve this. We already studied particular integral and complementary function. So particular integral, before that complementary function. See, first we solve d square minus 3d minus 4 is equal to 0. Right. So here see minus 1 and minus 3. So not possible. Then what is the solution? Minus b plus or minus. See, first find auxiliary equation. M square minus 3m plus minus 4 is equal to 0. Then minus 3 plus or minus root b square, that is 9 minus 4 into a into c, right, by 2 into 1. Then what is minus 3 plus or minus, right, that is plus 3, right, minus b, root 4 into 4 16, right, 16 plus 9, okay, we getting correct root 3 5 by 2. Then what, 3 root 5, 3 plus root 5 divided by 2, 3 minus root 5 divided by 2, sorry, here root 25 only, then here it is 5, then 8 by 2, 4, here 5 only, then minus 4 minus 1. Okay, so this is a direct, right. So 4 minus 1 is the root. Now I am clearing this all. So 4 minus 1 is the root means what is your solution? C1 e raised to 4 m1 is equal to 4, m2 is equal to minus 1. Correct? Yeah? Yes. If it is like that, C1 e raised to m1x, that is complementary function, plus C2 e raised to minus 1x, m2x. This is complementary function. Now what is our solution? Right? Y is equal to x square divided by, what we solved, d square minus, say, 3d minus 4. This only we getting. We have to write this as how x square function, right hand side x square come, how we solve it? We take x square divided by 4 we take out, then you can write this as 1 minus, right, minus 4 you take, then 1 plus 3 by 4 d, am I right? Alright. And minus d square divided by 4 all raised to minus 1. This go up, right? Now this is minus x square by 4 into c 1 plus nx. Then 1 minus 3 by 4d plus d square by 4 using binomial theorem expanding, right? So 1 plus c 1 plus x all raised to n is equal to 1 plus nx. This x I am taking as what, 3 by 4 d minus d square divided by 4. That value you substitute here for x, n you take as minus 1. Then this minus 1 coming here, then this become plus d by 4. D square by 4, this become minus 3 by 4d. Alright. Now we expand it, right. That is minus x square by 4 minus minus plus side, then 4 is 16 plus 3 by 16 plus 3 by 16 into differential of x square, that is 2x. Am I right? Differential of 2x, that is 2. Double differential of x square is 2. Then 2 by 16, that is 1 by 8. This is particular integral, right? Now what is the complete solution? Particular integral plus complementary function you find means you get the complete solution. Alright? Alright. So this kind of two differential equation we studied. Now see, x square d square y by dx square minus 2x dy by dx minus 4y equal to x square. This is Euler-Cauchy differential equation. Before that we seen exact differential equation. Alright. Now next class we focus on what is series solution of differential equation. Right. How to find a differential equation given. Okay. Now if it find the solution of a differential equation as a sum of a particular function in series manner, right? Anyway, we discuss based on that only we come to different special differential equation like Hermite differential equation, Legendre differential equation, okay, a Legendre differential equation and all we discuss. Okay, thank you.